Hi, good afternoon, and thank you for coming. My name is Tom Szumilla. I'm a mechanical engineer. I'm a general manager of company operations with a carbon technologies company, but that's my day job. In my spare time, let's get started. Today we're going to talk about the history of NASA design reference missions. That's humans to Mars, and we're going to talk quite a bit about the build-up to these missions. The design reference mission is a mission concept document designed by NASA on how to get humans to Mars. The DRM is not intended to be a definitive flight plan architecture, but lays out the current thinking of a mission flight plan based on the best science, engineering, and thinking of the day. The first documented formal DRM was released in 1993. It's been updated several times over the years. The last release was by NASA, was version 2007, and we'll get to that in a little bit. The DRM did not suddenly appear, but it is a child of many origins. It's a document of evolution, really, of ideas that have been generated over decades. In the last 60 years, there have been thousands of flight plan architectures that were developed both inside and outside of NASA, and many of these plans have contributed to where the DRM is today. Some early ideas were discarded, but later made a key component of the reference mission. At times, there have been efforts to update it frequently, and at other times, there were little reasons to update it, and it was unimpressive and no progress was made. The current evolution of mission plans kind of has solidified the thinking, and we'll come back to it at the end, on some of the basics of a conjunction class long stay mission in favor of a short stay, living off the land in situ research utilization, methane as some kind of fuel somewhere in the system, no use of the space station or moon. You can see the crew size, and an entire crew lands on the surface. Some other ideas that have been considered over the decades is, as I mentioned, the short class stay missions, about 40 days on the moon, and Venus flyby missions were once in the scheme of things, and we'll discuss that, the rationale for that. And manned flyby missions were seriously considered at one time. To get to the origin of these concepts, let's kind of start about 60 years ago. We're going to start with Dr. Wernher von Braun. And before we really get into what he did, let's talk about the age that he lived in. It was just after World War II. And it wasn't the space age, it wasn't the silicon age. There was the Cold War, there was industrialization, there was lots of machines. But machines needed human attention and maintenance. Robots only existed in science fiction. This was a different era than today. In this age, in 1948, Dr. von Braun wrote up a full-up mission. He wrote a technical specification with a launch date of 1965, and this later became known as the Mars Project. He envisioned and this Mars Project became a centerpiece in Collier's magazine in the 1950s, in the early 1950s. He envisioned an enormous scientific expedition which involved a fleet of 10 spacecraft with 70 crew members that would spend 443 days, that's a conjunction mission, a long stay mission, on the surface of Mars before returning to Earth. The spacecraft, the 7 passenger ships and 3 cargo ships, would be assembled in Earth orbit using materials supplied by reusable space shuttles. He calculated the size and weight of each ship and how much fuel, and came up with about 5 million metric tons. Once in Mars orbit, the crew would use telescopes to find a suitable site for their base camp near the equator. A manned wing craft would detach itself from one of the orbiting ships, as you can see, and glide down through the thick nitrogen atmosphere of Mars, which we know not to be true, and land on ice at the North Pole. The crew would then travel about 6,500 kilometers overland using crawlers to a base camp near the equator. There, the ground crew would make landing strips such that the other wing gliders could land on these strips near the equator. A skeleton crew would remain behind in the orbiting ships. At the end of the ground mission, the surface crew would remove the wings from the gliders, set them upright, and lift off from Earth. Von Braun was a rocket genius and visionary, and as I said, he was a man of his times. He based this enormous expedition on the large Antarctic expeditions of the day. For instance, the United States Navy had a mission to Antarctica, which included 5,000 men, 13 ships, and 23 aircraft. Because you have to realize this is pre-satellite communications time. Antarctic explorers were cut off from the rest of the world, and all the skills to deal with any problem had to be at hand. There were no satellite communications. Von Braun expected the Martian explorers to face similar problems and included a large multidisciplinary crew in his mission. He did not detail any precursor robotic missions to gather Mars data. Again, in the 21st century, we take for granted that a robotic probe can be successfully flown to anywhere in the solar system and return scientific data. But at von Braun's time, space probes did not exist, and there was no anticipation that a future robotic spacecraft, which is basically a machine, could successfully work without a human to tend to it. Machines needed people to tend to them. So as such, he anticipated no robotic precursors. The first rocket to Mars would be a full-up manned mission. In later years, the phrase the von Braun Paradigm was coined to describe von Braun's broad plan of human spaceflight, which essentially was a reusable space launch system, a space station, Moon, and Mars. In later years, he did revise his plan down substantially, but this version was made public. It was published in Collier's. It became part of a Disney series in the 1950s, and this is what became ingrained in the general public of the United States and the world. At the time, there were certain romantic notions about Mars. It had an atmosphere and probably water in the form of ice. Did it have advanced life forms? This was the 1950s, before the space age. Much of what we know about Mars was strictly based on telescopic observations. About every 15 years, Mars makes its closest approach to Earth, and this is the best time for Mars observations. There was an approach in 1956, and that was the last one before the space age. The next opposition for telescopic observations would be 1971. And we all know that in 1971, humans would find Mars to be a very different place than what it was thought to be in 1956. We're going to get into the first NASA mission, which was developed in 1960. And this was by the Lewis Research Center in Cleveland, Ohio. And interestingly, Lewis was already involved in nuclear thermal rocket research when they came up with this plan. So you can see they based their plan on things like heavy shielding against radiation, a crew size of 7. They believed in a short stay mission, 2 crewmen go to the surface. They needed a very large booster rocket, which we'll get into later. And as I mentioned, they were an outfit of NASA that was making nuclear thermal rockets, and they believed they needed nuclear thermal rockets to go to Mars. This is the Nova rocket to the far right, of course. You can see that in the early 1960s, NASA was seriously considering building this Nova rocket. It has a diameter of approximately 50-foot diameter as compared to the Saturn V, which is a 33-foot diameter. So this one was a monster. There were variations on the Nova, which was double to almost 1 million tons lift capacity. And this was being considered at the time for a moon mission. Now, of course, with a moon mission, the architecture changed, and as it turns out, a Saturn V was sufficient. And so the Nova rocket was never built. And this was much to the dismay of the people that were planning Mars missions, because they needed a Nova booster at the time with all their mission plans to get to Mars. Later, what was under serious consideration was piloted flyby missions, and this because piloted flyby missions did not require a great deal of propellant. Propellant was the major usage of fuel, of weight. The piloted missions allowed for what was called hot and cold trajectories. And a piloted flyby mission involved a trans-Mars injection from Earth orbit, a flyby of Mars with a gravity assist to come back to Earth. Recall that there were not any robots at the time, and humans were needed to tend to robots. Robotic spacecrafts were not something that could be deemed to operate successfully. So the advantage of a piloted flyby would be that humans would tend to robotic spacecraft right up to the time of approach in order to ensure the success of the probes. As the flyby craft approached Mars, several robotic probes would be launched from the flyby vehicle to the surface of Mars. So as the physics go, A Mars flyby craft would need to approach and swing around Mars at about 800,000 miles, and this would be an unsatisfying expedition at that distance. If the flyby craft approached too close, a more manageable distance that would be interesting for observations, the resultant Earth return velocity would be too high for aerobraking and would require the use of extensive braking propellant. So to get in closer, the physics show that a flyby mission can be accomplished with no additional penalty of propellant by including a Venus flyby as a braking maneuver. This was termed a hot trajectory, flying by Venus. An alternate trajectory would be to fly into the asteroid belt around the far side of the sun and return to Earth, and this was called a cold trajectory. The hot trajectory was the favorite back then. This is about 1960. Humans could visit Mars as well as Venus. It was a 2-for-1, if you will. And as we'll be seeing, this Venus flyby maneuver will be utilized in several more mission plans. So that was a flyby mission. There was some talk of, in the 1960s, of an excursion, and that is to say that no astronauts would be on the surface, but it was a plan that could return a sample. I'll go right to this. A vehicle would leave the Earth, perform a flyby, and return to Earth, but as it did a flyby, it would drop off automated space probes to land on Mars. And these would be dropped off by the humans. Now, by this time, they were starting to think that maybe robotic probes will be okay. But the big advantage of this kind of flyby mission of dropping probes and having them blast off from Mars, and they would be captured on the other side by the Earth flyby mission, was that a trained biologist would immediately be available to start looking at these samples. And that was considered a huge advantage. So this was seriously considered around 1960. This was somewhat of a grand tour. This mission as considered, and this doesn't really show the detail, but this mission would continue into the asteroid belt, a manned mission to the asteroid belt, and around the far side of the sun, where the argument was we could do simultaneous human observations of the sun on both sides of the sun at the same time. That was the early 1960s. Then along came Mariner 4. It was the first successful spacecraft, the first spacecraft to visit Mars, and it was a flyby mission. So here's Mariner 4, and here's Mars. But that's not the Mars that Mariner 4 saw. The technology back then, Mariner 4 took photographs typically like this. And this was very significant, in a turning point in Mars exploration back in the mid-1960s. It produced 21 blurry photographs, but it also returned some conclusions and data that went something like that Mars is a desolate and cratered place much like the moon, very uninteresting. It determined that the atmosphere is not 10% as dense as Earth's, but rather 1%, and carbon dioxide. And again, romantic notions of plant and animal life were largely discarded at this time. But the mission demonstrated that robotic probes could survive the environment space and provide useful data without a human tender. And so the rationale for the flyby missions no longer existed. Mariner 6 and 7 visited Mars shortly thereafter, and money was allocated at the same time for testing of nuclear thermal rockets. And as I mentioned before, these nuclear thermal rockets were not intended for the moon. I forgot one thing here. Here's an image of Mariner 4. Here's a similar image, and this is the Manoa-Fossey region. Here's a similar region taken by Mars Reconnaissance Orbiter. That's in the same general region there. And this is both images, that the first one you saw and this one are about a 250-mile stretch of image that you see. If the stretch was about 500 miles, this is what they might have seen. They would have seen channel valleys on Mars. That they flew by and saw such a narrow strip that this is a boring place. Why are we going here? Let me keep going here. But when Mariner 6 and 7 came by, they still discounted any romantic ideas about the moon, and it really was concluded it still looked a lot like Mars. And I do want to say that incidentally, when Mariner 6 went by, it spotted a large form on the ground, and it was named Nix Olympia. It wasn't until Mariner 7 came a few months later that they realized that this giant crater they thought they found was the largest volcano in the solar system. So the exploration of Mars kind of fell into a slumber around that point. Viking landed in 1976 and was a huge success by most standards. And they produced valuable data and proved conclusively what the atmospheric pressure and content is. As a follow-up to this Viking data, in 1978, NASA conducted a study, which was headed by Lewis Friedman, incidentally, that looked at the resources available on Mars for propellant production. So this is the first thought about ISRU and situ resource utilization on Mars. After consideration of many options, which included a carbon monoxide liquid oxygen fuel produced on Mars, a hydrogen oxygen fuel derived from Martian water, they hit upon a liquid methane oxygen propellant as the best candidate. The required hydrogen would be obtained from the electrolysis of Martian water. Benton Clark of Martin Marietta published the first papers on exploring the life implications of the Viking results in his paper entitled "The Viking Results, the Case for Man on Mars." However, as successful as the Viking program was, they were billed as the prospectors for the search of life on Mars, and they did not conclude that there is life on Mars. There were no follow-up missions, even robotic, and the next phase of Mars planning would occur outside of NASA. In subsequent years, this is after 1976, NASA became heavily involved in the Space Shuttle program and later the International Space Station. So in developments outside of NASA, that's where some advancements were made in Mars mission planning. In the early 1980s, a series of conferences took their name from the Benton Clark paper, and these were called, anyone? The Case for Mars. The conference brought together many interested in the manned exploration of Mars and provided new ideas on flight plans. Just a few years earlier, the Planetary Society was formed, headed by Carl Sagan and Louis Friedman, and proposed some additional plans for Mars exploration. Many of these plans included updated versions of the Flyby rendezvous missions, and new ideas arose on Mars-Earth cyclers, and the use of the shuttle, which was currently flying or about to fly, was considered to build up Mars infrastructure in Earth orbit, among many ideas. ISRU was also discussed to provide oxygen for the astronauts, as well as an oxidizer. And a lot of these considerations at that time were for a carbon monoxide oxygen propellant. In 1985, the Soviets, actually a CIA analysis concluded the Soviets were planning on a piloted flyby mission by 1992. The Soviets were getting all their ducks in a row, so to speak. They had a large inertia 80-ton booster. They had a space shuttle. It flew once. They had a shuttle. They had long duration stays in orbit, as well as a space station. This was seen as a threat by many and would by all measures mean a Soviet preeminence in space. And you can see some of the headlines of the day. Mars proponents from as far back as the 1970s, Senator and moonwalker Harrison Schmitt, who was a large proponent of Mars back in the early 1970s, pressed for NASA for a piloted flyby mission to counter the Soviet threat. NASA proposed a brute force program of dozens of shuttle flights and orbital assembly at the proposed space station Freedom. Hadn't flown yet. This, of course, went nowhere. The shuttles continued to fly, and their rationale for use was the construction of the space station, which would be a stepping stone to Mars. This basically followed the Braun Paradigm, which was shuttles, space station, moon, Mars. And case in fact, many of the mission plans developed in that era pre-assumed the use of the shuttle or an orbital hangar to assemble a Mars spacecraft. After Challenger exploded, there were many doubts and a reevaluation of the shuttle system. Although many changes were made and the shuttle did return to flight, the shuttles lost favor as a practical and useful launch vehicle for the assembly of a Mars spacecraft in orbit. Even the yet-to-fly space station Freedom, which was being redesigned to save on cost, would no longer be an orbital hangar for a Mars construction, but rather an orbital laboratory. This would be of little use to Mars vehicle construction. The rationale for the space shuttle continued to be the space station, but neither the shuttle or the station was being considered for future use in a Mars mission. And you can see at one time there was a competition with the Soviets, and political fortunes change all the time. When Mikhail Gorbachev came to power, in a spirit of détente, there were the proposals at the highest levels for a joint Soviet-U.S. mission, but these were never planned in any detail and they never went anywhere. In 1989, on the 20th anniversary of the moon landings, President Bush put up a plan to put Americans on Mars in the 21st century. This still stands as a major influence on Mars planning, but is best remembered for its overly grandiose plans. It was intended to be a Kennedy-style initiative and was declared on the steps of the Smithsonian. This plan incorporated several alternate mission concepts to reach the goal. The variations that were presented to President Bush were mostly just timelines, not really changes in mission plan. And every step, NASA seemed to insist that they needed the shuttles, they needed the space station, and they needed the moon. So this plan included, jumping ahead, a shuttle-derived heavy lifter, yet to be developed, construction of a space station Freedom, and perhaps even additional space stations to handle the load, return to the moon, set up infrastructure, and produce rocket fuel, a journey to Mars by launching from either the moon or from the space station Freedom. There was also a recommendation for additional studies in technologies such as life sciences to combat weightlessness. And I do want to say as a footnote, this 1989 document recommended that a successor to the shuttle be built in the 2000-2010 timeframe and described the shuttle as labor-intensive, expensive, and non-robust. This plan required a NASA budget increase of about $15 billion per year, which was more than double the NASA budget, and this, of course, was found to be unacceptable. In August of 1990, President Bush established a committee, which was headed by Norm Augustine. And what can I say? Norm Augustine was still around 30 years ago, to make recommendations for the space program. And the recommendations of the Augustine report was that NASA should focus on space and Earth science. And the president ordered NASA to implement these recommendations and to throw more water on these small embers of any remaining ambition. Again, in 1990, the Hubble Space Telescope was launched, and it was shortly thereafter found to be myopic, and this was a huge embarrassment to NASA. So Mars is not going anywhere in this early 90s period with NASA. Against this backdrop of this failed environment, engineers at Martin Marietta Corporation devised an alternate plan for a piloted Mars mission, which was termed, anybody? Mars Direct. It took this name since the plan involved no orbital assembly and no stopovers at the moon or a space station, and launched directly from the Earth to Mars. This was a huge departure from SEI and also shed many of the ideas of all the legacy plans of the previous 50 years that included the shuttle, space station, moon. This plan also incorporated some previous ideas in many ways. You can see what's up there, and I'll add that the use of methane fuel, as proposed, was not necessarily a new idea and had been considered as early as 1978, as we already mentioned. But the previous plans for methane included the mining and electrolysis of Martian water to obtain the hydrogen to make the methane. Some mission architectures even called for this operation to be done by humans on the moon Phobos, which is thought to have deposits of water ice. Obviously, this effort would require a great deal of investment and risk for an early mission, and the Mars Direct plan simplified all this by bringing a modest amount of hydrogen from Earth and reacting it directly with the Martian atmosphere. Artificial gravity had been considered in prior mission plans by NASA, but had been rejected in the latest SEI program. Similarly, long-stay conjunction-class missions have been considered as far back as von Braun, but had been rejected in the latest SEI program. Since ISRU requires the needed propellants for return to Earth, the landed mass to the Martian surface permitted transmars injection to be done with chemical rockets. Almost none of the mission plans of the previous years had considered this. They almost universally necessitated the use of nuclear thermal rockets. Finally, the plan was a break from the von Braun paradigm, namely the path of Mars need not be a reusable shuttle, space transportation, and the moon. This is something that had been in the public consciousness and perhaps still is. In 1993 and in subsequent years, the design reference mission, let's say from Mars Direct, NASA developed the design reference mission, which varied a little bit from the Mars Direct plan. In 1996, the mission plan was updated from the excitement that was generated from the Pathfinder and Mars Global Surveyor missions. Some of the differences from the design reference mission of 1993, this 1993 version required a 240-ton booster, which basically is a Nova-class rocket and doesn't exist, and nobody's had it on their drawing boards since about 1967. The mission plan was updated and it was removed, but there were some other considerations made in the 1977 update, 97 update. And I'd like to move ahead to just maybe a brief summary of what's here. And as you can see, what we have here is SEI, Mars Direct. This is the first official document called a Design Reference Mission, issued in 1993, and this was largely based off of Mars Direct. We have a Design Reference Mission that was issued in 1997, which was largely based on what was happening with some successes that were occurring on Mars exploration. And in 2007, based on what was happening with Project Constellation, the program was again developed because there was currently being built 140-ton booster. So you can see some of the differences. Now, I understand Mars Direct caught some flack for only having 4 astronauts on board. You can see that the Space Exploration Initiative, we're going to send 4 astronauts to Mars. And the crew size in subsequent years became 6, launching from the Space Station Freedom. Some of the more interesting things, perhaps, is the use of ISRU, which in the Space Exploration Initiative on the Martian surface was going to be done by the splitting of carbon dioxide into oxygen and rejecting the carbon. No fuel was being produced. There was also later water extraction would be done. Of course, we know that Mars Direct produced methane and oxygen on the Martian surface, and even the first reference mission had a very similar strategy, although the amount was reduced, and that's because more infrastructure was being left in Mars orbit, which incidentally, because of more infrastructure, meant the use of nuclear thermal rockets were required. And nuclear thermal rockets are something that this space program needs, but they're perhaps still a few years out because there's just no money being spent on it. So I want to cover the latest design reference mission, which is only producing oxygen on the surface. It's not producing any methane like that. And that was an analysis done by NASA where they felt that the extra weight and energy utilization was too high. But I do want to add, they're requiring 7 to 12 launches now for a human-rated mission. And I'd like to say thank you. I think we've got time for 1 or 2 questions. Good, I said it all. Sure.
It sounds like there's more reconfiguration in mind. That number of 7 to 12 launches is probably not going to work.
What they're doing in the 7 to 12 launches is a lot of times they're launching a first stage. They're launching a Saturn V class rocket that has a nuclear thermal rocket upper stage, and then mating that with another rocket. So you need basically 6 launches for 3 rated craft. Like Mars Direct is sending, if you will, 2 direct launches. They're gonna orbit and mate a nuclear thermal rocket with a cargo, and then send that. So they need 3 NTR launches, 3 cargo launches. They mate them in orbit, and they go.
Take more questions.